Today we're going to look again at two-column proofs. Two-column proofs, it's a form of deductive reasoning. Use numbered statements and reasons to show a logical argument. And that's it, right? Okay, so what we started with yesterday was algebraic proof, because it's something you guys know how to do well. So we're learning the format of the two-column proof using something that we already know, the algebra. So does anybody remember from yesterday, where do we begin? Given statement. Kendall, you're right. We always begin at the beginning. It's a very nice place to start. All right, so we're going to start by writing our algebraic statement. We can write that because it's given. Okay. Now I'm going to proceed with a logical argument. So I'm trying to prove that x equals -5. Algebraically, what would be my next logical step? Okay, good. So remember our reasons. You guys are kind of calling out those reasons. We're using the distributive property. And when we do that, we're distributing the multiplication, right, to both x and -6. So I get 2x minus 12 equals 5x plus 3. What would be a next logical step? Add. What do you want to add? Add 12 to both sides. So I used the addition property. We're almost there. What's the next logical step? Good, I'm going to subtract 5x from both sides. And that was a subtraction, right? Okay. Last step that I have to take, division, excellent. So I'm just going to go ahead and divide both of these by -3. And I use division property. Very good. What I check for then, I'm looking to see if this last statement that I made matches what I'm trying to prove. Is it exactly what I'm trying to prove? Then I'm done with my proof. So now we're going to look at what happens if I have this picture. So my picture is part of my given statement. And I have to read the information from the diagram. So I'm always going to start, remember, with what's given to me. In my picture, I know that QR is x plus 1. I know that RS is 3, and I know that the entire length of this QS is 2x minus 1. All of that information can be found in my picture. So I'm going to list that. QR equals x plus 1. RS equals 3. QS equals 2x minus 1. All of that is given information, and it's okay if I make it in one statement. And when I put my numbers in here, I want to make sure for my next step that I line those up with my statement and my reason. I need to make a next reason or next statement that follows from this that somehow is going to allow me to show that x equals 5. So I remember, drawing way back on my chapter 1 memory, I can add the small part to the small part and make it equal to the whole thing. So I know I can add QR plus RS, and that's going to be equal to QS. So property or postulate that lets me do this. It's called the segment addition postulate. What would be a next logical thing to do if I eventually need to solve for a number? Put the numbers in. That's right. If I know these values, can I put them into this equation? What do we call that when we replace the numbers? Substitution. All right, very good. So QR is x plus 1. RS is 3. And I know QS is 2x minus 1. And I just used the substitution property to replace those known values for those letter names. Algebra from here. I have to combine my like terms. So I should have x plus 4 equals 2x minus 1. There's no property name for that. We just say it's a simplify. I'm going to then subtract 2x from both sides. So 1x minus 2x gives me that negative 1x. All right, x's are on the left. I need this 4 to go over to the right-hand side, so I'm going to subtract 4. Somebody asked me yesterday, is it okay if we use the same property 2 times in a row? Yes, as long as it's appropriate. Does that look exactly like I need it to look? What do I have to do? Very good. So I'm going to divide by a negative 1 on both sides using the division property. Now, my last statement looks exactly like what I'm trying to prove, so I know that I'm done. This picture is a little more complicated than the last one. So we had segments in the last picture. We have angles in this picture. I'm still going to do the same kind of idea that I did before. I can add the 2 small parts. One of them is VUK. That is 9x plus 6. The other one is KUT, and that is 104 degrees. I can add my 2 angle parts together to get the whole angle measure, correct? So the whole thing would be represented by this 26x plus 8. Okay? All right. Same basic idea as we did the last time. We're using the information in our picture and kind of those words to go ahead and identify our given information. I'm going to go ahead here. So the given information is all those angle measurements. The measure of angle VUK is equal to 9x plus 6. The measure of angle KUT is equal to 104. And the measure of angle VUT, remember that's the whole thing, that is 26x plus 8. All of that information is given to me in my picture or in the words describing the picture. I can add 2 parts to get the whole thing. So I just have to write that out. The measure of angle VUK plus the measure of angle KUT is equal to the measure of angle VUT. Sorry, I kind of ran it over here. This is the angle addition postulate. Right? We had segment addition, we had angle addition. Now, I have this long equation, and all it has is these names in it. I'm going to go ahead and substitute my values in. So I'm going to go ahead and say 9x plus 6, that's VUK, plus KUT, that's 104, is equal to 26x plus 8. So same kind of reason we used last proof. Substitution lets us replace the numeric values in our equation, right? Now I have algebra. Combine your like terms. Remember, we just called it simplify. Next step I'm going to take, I'm going to go ahead and subtract 8 from both sides. So that was the subtraction property. I got to get my x's over to the other side, right? So I'm going to subtract 9x. Again, using subtraction. Then I'm going to divide, right? 102 divided by 17 is 6. So that was the division property. Does that look exactly like what I'm supposed to prove? So what's wrong with it? The order is flipped. So I'm going to go ahead and flip that and say x equals 6. What property is it that allows me to switch those? Reflexive would say x equals x. Symmetric is the same forward and backward.